Welcome to the deep dive. If you're tuning in, you're probably looking for that quick, smart take on complex science and policy issues. Today we're diving into something critical: sustainable fisheries management. Everyone knows we need good data to manage fish stocks sustainably, for food security, for ocean health. But here's the catch: getting that data. It's incredibly difficult. Our focus today is largely on a key paper: opportunities to improve fisheries management through innovative technology and advanced data systems. Darcy Bradley is the lead author from 2019, and it's what's called a GOTY paper, which, if you haven't heard the term, it's basically meant to provoke, to stir things up and spark new thinking in fishery science. Let's unpack this.
Right, and what Bradley and the team looked into is, well, it's a bit of a puzzle. We're surrounded by amazing tech sensors, smartphones, AI, cloud computing, yet somehow most fisheries around the world are still running on paper logbooks, maybe pencils too. So the paper asks, why aren't these high-tech, often pretty affordable systems the standard? Why are they still the exception, and what can we actually do about it?
And the stakes couldn't be higher, really. We're talking about over 80% of global fish stocks being classified as data poor. Think about that. Managers making crucial decisions about this massive global resource, this vital food source, essentially blindfolded.
Exactly. You can't have effective conservation, you can't ensure economic stability for fishing communities without decent, consistent data. It's just impossible. And part of the difficulty, well, it comes down to the fish themselves. They're underwater, hard to see, they move around a lot, often across national borders. So the traditional ways of collecting data, sending people out on boats as observers, relying on fishers to fill out paper logs, it's slow, it's expensive.
And prone to errors, I imagine. Transcription mistakes, things not being filled out right.
Oh, definitely. Quality control is a huge headache. Plus, it's just inherently time-consuming.
And that time lag, that delay between catching the fish and getting the data analyzed, that seems like the real killer, especially now.
Absolutely. The ocean's changing fast, climate change, shifting currents, you name it. Managers need information now or close to it to make smart adjustments. If your data system takes 6 months or even a year to tell you what happened, you're always managing based on the past. You're constantly behind the curve.
Fighting yesterday's war, basically.
Precisely. And the paper gives some stark examples. Take the conventional paper systems. Forget the slowness for a second. Think about transcription errors. No standardization between fisheries, data that just isn't detailed enough spatially. Like the northwestern Hawaiian Islands lobster fishery. It got shut down back in 2000. Why? Because the managers just didn't trust the data.
They couldn't tell where the lobsters were being caught accurately enough.
Right. The spatial data wasn't fine enough to properly assess the stock's health in different areas. So the precautionary approach, shut it all down. Huge economic impact.
And that's in a relatively data-rich industrial fishery context. What about smaller scale or recreational fisheries?
It gets even worse there. They're often seen as too hard to monitor, or the data collection is patchy at best. The Gulf of Mexico red snapper recreational fishery is just a painful case study. They had such a lag in processing the catch data that they only realized retrospectively, looking back, that the recreational fishermen had blown past their quota every single year from 2007 to 2013.
Wow. So completely flying blind.
Totally.
Yeah.
Driving the fishery while looking firmly in the rearview mirror, it almost guarantees you'll eventually hit a wall.
Okay, so the problem is clear. We're slow, we're often working with incomplete or delayed information. The obvious answer seems to be technology. And this is where it gets really interesting, because the tools aren't some sci-fi fantasy. They're often based on stuff we use every day.
Exactly. We're talking mobile phones, tablets, cloud computing, things that have become way more accessible and affordable. The first big category the paper discusses is electronic monitoring, or EM.
Right, the cameras on boats idea.
Yeah. Usually CCTV systems, maybe high-res still cameras, combined with GPS to track where the boat is and what it's doing. It's designed as an alternative, often a cheaper one in the long run, to having a human observer on board, recording catch, discards, fishing effort, that sort of thing.
And does it work? Is it actually being used effectively?
Oh, yeah, definitely. There are trials and full implementations globally. Canada's BC hook and line groundfish fishery is a prime example. They've mandated 100% EM coverage since way back in 2006. It's proven effective for verifying compliance, like with discard rules.
Okay, so the tech is viable, But you mentioned earlier, resistance.
Ah, yes. This is where the human element crashes into the tech, putting cameras on boats that immediately raises flags for fishers, privacy concerns, feeling like Big Brother is watching.
Control issues, basically. Who owns that footage? Who gets to see it?
Exactly. Even if it saves money long term, that initial hurdle of installing a monitoring system that watches your every move is significant.
That makes sense. So EM is one piece. What about less invasive tech?
Well, there's electronic reporting, or ER. This is more straightforward, really. Think electronic logbooks, ELBs, instead of paper ones. Or e-tickets, which are electronic landing receipts when fishers sell their catch. It's just digitizing the existing reporting process.
And the benefits there are.
Pretty immediate. The paper points to Alaska's crab and groundfish fisheries switching to e-tickets. Costs went way down. No printing, handling, storing paper forms. But more importantly, the data was available almost instantly, centrally. Much faster, fewer errors, more transparent.
Okay. And then you mentioned mobile phones. Apps, I assume.
Yep, mobile computing. Everyone's got a smartphone. There are tons of recreational fishing apps out there, like FishBrain. The paper mentions it logged something like 3.7 million catches globally. Huge amount of potential data.
Potential being the key word.
Right. The problem is that data is rarely collected in a way that's standardized or easily usable for actual fisheries management. It's mostly for bragging rights among anglers.
So how do apps become actually useful for management?
When they close the loop. When the data collected feeds back into near real-time action, good examples are NOAA's Turtle Watch in Hawaii, or the eCatch app used by groundfish fishers on the U.S. West Coast. These systems can predict hotspots, say, where turtles are likely to be, and alert fishers in near real time.
Ah, so the fishers can actually use the system to avoid bycatch, change where they fish, adapt on the fly.
Exactly. That's dynamic management in action, using timely data to change behavior immediately.
And looking even further ahead, AI.
Yeah, that's the cutting edge. Artificial intelligence, machine learning, specifically computer vision. Systems like CatchMeasure are being developed to automatically identify fish species and measure them from EM camera footage.
Taking the human review out of the loop, or at least reducing it.
Potentially, yes. Speeding things up even more. And the ultimate vision really is these integrated fishery information systems, IFOMs. Think of a central dashboard pulling in data from EM, ER, vessel tracking, environmental sensors. Everything, all synthesized for truly dynamic, real-time decision-making.
Okay, so we've got the problem data gaps leading to crises like the red snapper situation. And we've got this amazing toolkit, EM, ER, apps, AI. So why isn't this technology everywhere? Why are we still talking about data poverty in fisheries? This is the core question Bradley and her colleagues tackle writing.
It is, and their argument is powerful. The main roadblocks aren't really about the technology itself anymore. They're organizational. They're sociological, human factors.
Okay.
Yeah.
What are the big ones they identify?
They lay out 4 main barriers. First one, simple economics, cost and capital. Yes, maybe EM is cheaper than paying for human observers over, say, 5 years, but that upfront cost to buy and install the system. The paper quotes an average of over $13,000 US per vessel for EM. That's a massive hurdle, especially for smaller boats or fisheries in developing countries.
Right, the classic initial investment problem. Even if it pays off later, you need the capital now. Who bridges that gap?
Yeah.
Policy, industry.
It often needs things like government subsidies or specific loan programs, but that leads right into the second barrier, legal and bureaucratic inertia.
The system resisting change.
You got it. It sounds almost comical, but they point out how some U.S. federal fisheries legally required vessels to submit paper logbooks until very recently. Even if the boat had the latest electronic reporting system, the law hadn't caught up. Outdated regulations, institutional foot dragging, it just stalls progress.
That paper logbook example is kind of perfect, isn't it? Governance moving at a glacial pace compared to tech. What's barrier number 3?
Lack of data standards. This one really hit the recreational app market hard. You had all these developers creating cool fishing apps, collecting tons of data points, but nobody agreed. Not the developers, not the management agencies, on what data to collect, how to format it, how to share it securely.
So chaos.
Pretty much. Lots of apps doing similar things, but none compatible. Fishers lost interest, developers went bust, and managers were left with piles of data they couldn't actually integrate or trust. A huge missed opportunity.
Okay, cost, bureaucracy, lack of standards.
Yeah.
What's the 4th? And you hinted it might be the biggest.
Yeah, the authors argue this is the most critical one. Lack of trust and buy-in from fishers.
Ah, back to the human element.
Absolutely. Think about it from the fisher's perspective. You invest time, maybe money, collecting detailed data about your fishing. Where does it go? Often into what feels like a black box within a government agency. And what comes out months or years later? Maybe new regulations, tighter quotas, closed areas.
So the data feels like a weapon used against them, not a tool for improvement.
That's the perception and often the reality in top-down systems. There's this pervasive fear. Giving up detailed location data, letting cameras watch you. It'll reveal your secret fishing spots, your trade secrets, or it's just about losing control, losing privacy and agency over your own operation. If there's no trust, no clear benefit to the fisher, why would they cooperate fully and provide accurate data? They're actively disincentivized.
Okay, that trust deficit really does seem like the crux of it. If the relationship is fundamentally adversarial, the best tech in the world won't fix it. So what's the alternative? How do Bradley et al. Suggest we move forward?
They propose a fundamental shift towards what they call a transdisciplinary management approach.
Transdisciplinary, that sounds academic. What does it mean in practice?
It's more than just consultation, where managers kind of ask fishers for input after the fact. It means co-design, true collaboration. It involves bringing all the relevant people to the table right from the start. Fishers, scientists, managers, processors, maybe NGOs, community leaders. And together, they jointly define the actual problem they're trying to solve. They agree on the methods, including the technology, and they decide together what the solution looks like.
So the fisher isn't just a data point provider anymore. They're actively involved in designing the system itself, an equal partner.
That's the goal. Early and equal participation. Because when you do that, the technology stops being something imposed on fishers and becomes a tool for them. It becomes a value proposition, as the paper puts it. The key is designing systems with clear feedback loops, ensuring fishers see direct benefits from the data they help collect.
Benefits like?
Could be anything. Maybe the data helps them fish more efficiently, avoid bycatch hotspots, save fuel. Or maybe transparent. Verified data helps them get better prices, access premium markets, or achieve sustainability certifications.
Making the data work for them, not just on them.
Exactly, and we already see elements of this working. It's not just theoretical.
Examples.
Well, that British Columbia groundfish EM program we mentioned, a big reason it succeeded was the collaborative problem-solving between the fishing industry and the government. They worked together to figure out how to reliably monitor tricky quotas like yellow eye rockfish.
So shared problem, shared solution design.
Right, or look at lower tech examples. A study in Peru showed how small-scale fishers used simple radios to share real-time info on where sea turtles were accidentally being caught. Fishers voluntarily avoided those areas, and in return, they got useful oceanographic data shared back, helping their fishing. It created a win-win based purely on shared information and trust.
Okay, the transdisciplinary co-design model sounds really promising. It directly tackles that trust issue by changing the power dynamic. But, even good ideas can have downsides. Are there risks or potential unintended consequences we need to watch out for with this flood of new real-time data? Oh, absolutely. The paper flags several important ones. The first is a bit ironic. The technology can make fishing so efficient that it actually accelerates overfishing.
Wait, how? Better data is supposed to prevent overfishing.
Right, but think about information sharing. The example given is the Northumberland lobster fishery. New tech allowed fishers to share info, coordinate better, and landings shot up dramatically. But the management system couldn't adapt quickly enough to that increased efficiency, and the stocks got depleted faster than ever. The tech outpaced the governance.
Wow. Okay, so efficiency itself can be a double-edged sword if management isn't agile enough. What else?
A second major risk is market manipulation. This is fascinating. In Kerala, India, mobile phones were introduced, hoping to empower fishers by giving them real-time market prices. Sounds good. More information should mean better bargaining power for the fishers.
That was the idea, but what actually happened? The buyers used the technology more effectively. They could see all the prices instantly, coordinate amongst themselves, and essentially form buyer cartels. They ended up fixing prices lower, undermining the fisher's position. The tech created a new power imbalance, favoring the middlemen.
Ouch. So transparency doesn't automatically benefit the primary producer? That's a sobering thought. Any other big risks?
Yes, a third one is that even with better data, even if it's co-designed, differing perceptions can still fuel conflict. They mention the North Sea flatfish fishery. Fishers, using their own observations and maybe new data tools, were seeing signs of stock recovery, but the official scientific assessments based on longer-term models disagreed. The policymakers stuck with the models, imposing quotas the fishers felt were unjustified.
So even with data, if people interpret it differently or trust different sources, you still have conflict. The data itself doesn't magically create consensus.
Exactly. It proves that trust, shared understanding, and how we interpret data are just as crucial as the data collection itself. Hashtag, tag, tag, outro.
So wrapping this up, the big message from this Bradley paper, this Godey piece, seems pretty clear. We've largely cracked the technical challenges of getting better fisheries data. We have the tools. But the real bottlenecks now are organizational. They're sociological. It boils down to trust, governance, and building truly collaborative systems.
That's right. The goal has to be creating these genuine win-win scenarios where both the managers trying to conserve stocks and the harvesters making a living actually benefit from improved shared data.
It's about engineering that collaboration, not just engineering the tech.
So what does this all mean? Well, maybe the most powerful aspect of these new technologies is how they drastically shorten that time lag, the delay between seeing something happen in the ocean and being able to react managerially. The really good question now, maybe the provocation for you to think about, isn't just should we use EM or which app is best? It's deeper. How do we adapt our governance systems, our laws, our policies, our decision-making processes to actually use that rapid feedback effectively? How do we institutionalize continuous collaborative adaptation?
And crucially, how do we do that in a way that ensures improved efficiency doesn't just lead to overconfidence or worse, faster depletion?
Exactly. That question of embedding regulatory agility and shared responsibility into the system, that's probably the defining challenge for the next decade of fisheries management.